Hello, hello. Hi, everyone. Welcome to the room. Hi, welcome to our first ever Ray of Hope Accelerator Demo Day. We're really excited to be featuring our 2024 cohorts. And yeah, our first ever demo day here at the Biomimicry Institute. I am Maëlys Renaud, Program Manager of the Accelerator, and it's a pleasure to be your host today with my colleague Sarah McInerney. We're so excited to have you join today's events. I'm going to start a poll, so while people are trickling in, you can take a couple minutes to check this out. And you should be able to see the poll on your screen, nature's blueprint. I invite you to pick the best definition for nature-inspired technology. Hi.
Welcome, everyone.
Please take a moment to breathe, stretch as we welcome participants. And I can see the answers coming through. All right. I'll give everyone one more minute to join the room to read through these definitions. And I'll close that in about 10, 15 seconds. All right, let's reach 100 responses here. Oh my God, it's so amazing to see you all in the room. Thank you so much. And in 5. All right. I'll end the poll now. Thank you so much all for being here today. We're really excited to have you for our first ever demo day. We have a great number of participants in this room, and maybe before moving on, thank you for responding to the poll. I'm going to share the results with you here. All right. The question was, which of the following best defines a nature-inspired technology? And I see that you mostly picked our Biomimicry Institute definition, technologies that learn from and mimic biological strategies that have evolved over 3.8 billion years. The other definitions are the first two ones, definitions of nature tech by Nature Tech Collective and Nature for Climate. We see a different variation, one being more focused on nature-based solutions. And the last one is a definition of biotech. So these are not exclusive. Nature-inspired technologies can be nature-based solution, can be biotech solutions. They're a little bit different. I won't be dwelling on this, but I just wanted to clarify for everyone in the room the focus of our event today to support, welcome, and share nature-inspired startups, technologies, and founders. I'll move on, and I just wanted to introduce myself and introduce my colleague, Sarah. I'm Maëlys Renaud. I'm originally from Brittany, France. I'm currently based in Los Angeles, California. I bring to the team a chemistry background focused on materials, business law, and VC. And I've been just so thrilled to be able to work with these amazing founders for now a year and a half. And I'm excited to have Cohort 2024 featured today. And I'll pass it over to Sarah.
Hello, everyone. Sorry, my screen was off. I did not realize. I will be running kind of technical pieces in the background, so apologies if my eyes seem to wander from time to time. But thank you all for being here. I'm so excited to see 145 people here today. It's amazing. So yeah, thank you all. We're so excited to share this 2024 cohort with you all. My role here is I'm the program director here at the Biomimicry Institute. I've been working with incredible founders here through the Ray of Hope program for the past 3 years. My background is as I'm a biologist by fundamental training. I'm sure we've all worn many hats. But I grew up in Ireland and then I moved here to the US to explore my PhD in integrated bioscience. And I got to kind of compile all my interests into one 5-year program. So I focused on the potential of nature-inspired solutions to advance corporate sustainability through both design and behavior. So really that overlap between psychology, sustainability, and impact. So really happy to be able to do the work that I do here today with the startups that I get to work with. So yeah, that is all from me. And I'll hand it back over to you, Miley.
Thanks, Sarah. I'm so lucky to have such an incredible teammate to work so closely with every day. I would love to hear more about you in the room. It's Valentine's Day a little later this week. So I would love it if you could give me a heart if you are an investor in the room. Okay. I would love to see any heart reaction if you are in R&D or innovation, if you work at a corporate or as a designer, as a researcher. Are we seeing some hearts? Oh, yes. And then I would love it if you could give me a heart if you're a biomimicry nature inspiration lover in the room. Thank you so much. Please feel free to enter the chat. This will be our main communication points for any questions that you have throughout for our team members here in the room and for the founders. Feel free to let us know where you are in the world, who you are, and what brings you here today. And on behalf of the Institute, our brilliant team, our funders and partners, and the 10 game changer companies presenting today, thank you so much for joining us today. Here is a beautiful photo taken from our nature retreat in September. And I would like to take you in the woods with us today. Maybe here in the Catskills Mountain, north of New York City, where we gathered at the end of New York Climate Week in September. And I would like to take a moment to acknowledge the incredibly challenging times that we are in today in the US, internationally as well. And we support founders from around the world. And today we have a global audience. So I just wanted to ground us in that. And with that in mind, I would like to ask everyone in this circle today to respect the diverse audience and the different perspectives that we have in the room. Please stay muted at all time as we take you through this incredible pitch session. And you'll have an opportunity to chat in the breakout room session a little later. So please engage respectfully in the chats. Be mindful of time when you ask questions, and yeah, let's ensure that these founders have a chance to present their technology in this context. For the best experience, stay on speaker view during the pitches and use the chat for comments and questions. And here is the agenda for today. Now that we're grounded, I'll give a short introduction about the Ray of Hope Accelerator. I'm really excited to have the honor for opening remarks by Amanda Sturgeon, the CEO of the Biomimicry Institute. And then we'll dive right in pitches. We have 5 startups go first. Then we'll have a short breakout room session for 7 minutes. And we'll do it all over again with another set of 5 amazing startups. So first, nature-inspired startups. We had that poll a little bit earlier. And I confirm here that startups in our view and perspectives at the Institute that are nature-inspired learn from and mimic biological strategies that have evolved over 3.8 billion years. We support technologies that have evolved from an understanding of biological systems, just like Swiss startup Seprify from Cohort 2021. They're inspired by this little cute, bright white beetle found in Southeast Asia. And the team at Seprify is mimicking the scales structure, those white scale structure with cellulose to create a safe and highly performant white pigment. So I encourage you to check out Seprify because they recently built their pilot plant facility and have that ability to expand very rapidly right now. We support startups that are grounded in deep scientific research. just like the Swedish company Retin, also from the cohort 2021. They're inspired by the way diatoms form their cell wall with silica and aquaporins. And they're developing a breakthrough purification technology for water and more. And finally, we support technologies that are enabling bio-inspired solutions, just like Fusion Bionic, based in Germany from cohort 2022. They're creating laser-generated surface textures inspired by textures found in nature. That's opening new possibilities for functionalized surfaces. I'm so excited to tell you that they recently announced a partnership with another startup from 2022 cohorts, member Mfico, and they're based in the UK. And I believe June Kamei might be in the room here today. So June, if you're in the room, feel free to enter the chat here and say hi. So there is like a wide range of variety in terms of nature-inspired startups. The startups that we support are from around the world, across industries, and we're here to support them, support their growth, and all of them are really here to answer to the world's most pressing environmental changes. We welcome them from pre-seed to Series A across industries with that very strong scientific and technology foundation, usually starting at TRL.
Uso o mouse? No, peraí, para baixo.
Sorry about that. Lucky me. If you're unmuted, I'll see you right away. I really encourage you to discover more about our Ray of Hope Accelerator. Feel free to check out our website. We recently published our 5-year impact report, covering what we have done and the startups that we've supported over the past 5 years. And yeah, check out our how to apply page. It includes our selection criteria, eligibility criteria, and we would love to chat with you about all of this. And over to Sarah.
Awesome. Thank you. Well, we are so excited to share that over the years, we have had the pleasure to be able to build a portfolio of over 49 nature-inspired startups who have raised over 125 million in follow-on funding since engagement with our program. So we couldn't be more prouder of their success, but also the success of this portfolio as a whole, with 48 of these 49 startups still scaling and thriving today. It is a unique number amongst the accelerator world that is out there. So it really is just a clear testament to the opportunity and demand for these types of nature-inspired solutions in the world and across so many sectors. So we have startups and companies coming from textiles, energy sector, healthcare, agriculture, infrastructure, coastal restoration, and nearly everything else in between. So we really are extremely proud of the success and the scale at which this accelerator has grown and the technology that we've been able to support. But really that couldn't be possible. If we can jump to the next slide. If I can click, thank you. Without these people who are the incredible change makers and founders that lead the front behind all these incredible technologies. So we've had the privilege of working with these change makers from literally every corner of the world. And we've had incredible PhDs spinning out their research from academia. We have nature explorers who just want to make a change in the conservation world and trying to make an impact through technology. And we have industry leaders who have found a pain point within their sector and have turned to developing a spin out and a technology to address that need through nature-inspired solutions. So all the experiences, all the backgrounds, all the knowledge coming together, it really just ensures the potential for this impact to actually create a nature positive future. So we couldn't be more proud or more excited about the incredible group of founders that we get to work with through our alumni, but also through the incredible founders that you're going to meet today. So thank you again all for being here. It's been a 6-month journey with these incredible founders, and I'm just so excited to have this celebratory call with all of you here today. But on that, I will actually, until we see what all these change makers have for us next down the road, I'm actually going to pass it over to our CEO, Amanda, to share some insights about what we're doing here at the org at the Biomimicry Institute. So over to you, Amanda. if you're with us.
I'm going to show the screen actually, Amanda, and I'll pass the slides, please.
Okay.
All right, I'll show the slides again. Thank you.
Okay, sorry, yeah, I can't
All
see
good.
at the moment.
Here, can you see my slideshow?
Yep, there we go. All right, hello everybody. Lovely to see so many people joining us today. I am calling in from the land of the Lumi, Nooksack, and Samish nations, also known as the Pacific Northwest. It's a cold day here today, but really lovely to be with you. I wanted to share a little bit more around the context of the Ray of Hope program within the Biomimicry Institute's strategic plan. And so you have a bit more of a context of the work that we're trying to do as a whole as well before we get into the pitches from our amazing startups. Next slide, please, Maylise. So you'll all be familiar with the Biomimicry Institute founder, I'm sure, Janine Benyus. So I just want to sort of pull from the roots of Janine, and that really what our work here, especially with the Ray of Hope program, is about changing the world to rebuild our relationship with nature, but also for us to build an eco-literacy, if you like, around asking how would nature solve this. We think there's 3.8 billion years of genius within the evolution of nature. It's pretty much solved every problem, every system we need is there as inspiration to take from for all of the challenges that we're facing, whether those be climate change, biodiversity loss, social challenges, equity, inclusion. Really, we can look to nature for inspiration for almost every challenge that we're facing. And we seem to have lost that relationship, especially over the last 150 years. And that understanding of our natural world and natural systems. So underlying all of our work is that premise. Next slide, please. We launched a new strategy just last year in September, so not even 6 months ago. And I just wanted to introduce you to our theory of change on a page. You can find this on our website too. But the Biomimicry Institute is really trying to solve 3 key problems. Firstly, the polycrisis of climate change and biodiversity loss. Secondly, our disconnection from nature. And thirdly, moving us from the take, make, waste society that perpetuates inequity and also toxicity and overconsumption. We do that by through 3 programs, and you can take a look at our theory of change a little bit more. We've got identified sort of clear outcomes, and one of the outcomes that Ray of Hope particularly helps us address is really this take, make, waste society, and how we might pivot to a regenerative one. Next one, please. So we're doing that through 3 components. This program, Ray of Hope, is really about enabling a series of, if you like, an innovation ecosystem. We know that there's about 500,000 amazing research reports around how we might learn from nature, sitting in academia's, long research or thesis catalogs. We know there's an amazing source of knowledge and information to be tapped, but there are still not enough bio-inspired startups and innovations happening. So Ray of Hope is really seeking to create, if you like, an innovation ecosystem to get those ideas fed from academia and research into startups, and then supporting them to get past the valley of death into investment and scaling. So our Ray of Hope program is really about us enabling an entire innovation ecosystem to start to flow. Next one, please. Across the organization, the Ray of Hope program is really sitting in our innovation scope of work, but we also seek to bring inspiration to others through the reconnection of nature and people through our Ask Nature program, and get the inspiration to innovation sort of system working through also having a community series of events, learnings through our Ask Nature Hive. So So the Ray of Hope program, I think, is important to see it not just in sort of isolation, but as part of an ecosystem of moving inspiration through to amplification, so that we can create an innovation pipeline through an entire really ecosystem of learning, sharing, connecting, and enabling. Next, please. So hopefully you've had a chance to look at the Ray of Hope 5-year impact report that was released just not even a month ago. It has some great statistics in there of the success of this program. It's pretty unusual to have so many of the startups that have gone through to still be in business, and many of them thriving, to you know, as Sarah mentioned, you know, so much continued investment in the companies. We are really proud also that 35% of the portfolio are women-led, as typically you know, startups in this space are not. That it's also a global program with 15 countries represented, and that we've had the chance to support almost 50 companies so far to date. We're really proud of the work that's been done. I encourage you to take a look at the impact report if you haven't already. And I think as soon as you hear more from these startups, you'll learn sort of why this program has been so successful. Their brilliance is really incredible in the kinds of solutions that they're solving and the way that they're looking to nature to solve them. And in our impact report, you can also see some of the impact metrics for what has resulted from these startups coming into business. So with that, I'm going to hand it back to Sarah, I believe, to start our pitches today.
Thank you so much, Amanda. I'll take over for a little bit here. I am so excited to have you hear 10 pitches from 10 amazing companies. Just as a little bit of understanding here, each founder is going to have 4 minutes to present their nature-inspired technology and business. You'll hear us at the 3-minute and 30-second mark to keep track of time. We'll have 2 lineups of 5 startups, and we're about to jump in very soon. Before we jump in, I would love, in alignment with Techstars' spirit, to see if you could embody the give first philosophy. Our ask of you today is that you find at least one company that you could be helpful to. Maybe it is an introduction to a customer, a potential mentor, another mission-aligned investor. If everyone who tuned in today could do one thing, this team's impact will be even greater. So without more waiting here, we're going to introduce the first pitches. And Mary, you'll be up next with Recycle. Whenever you're ready.
Yeah, I'll jump in here. Hello, it's great to kick this off, and I'm just really excited to see how many people are in this room today. It's makes me feel very optimistic about the future of nature-inspired technology. I'm Mary. I'm the CEO and co-founder of Recycle. We're a material innovation company mimicking shell formation to produce a carbon sequestering cement. And I'm going to tell you how we got here. This is what New York Harbor used to look like. It was home to one of the world's largest reef systems, engineered by the oyster, whose material acted as natural infrastructure against wave energy, reducing sea level rise while promoting biodiversity. As a designer, I was struck by the intrinsic contradiction of climate resilient building. This led me to get involved in marine restoration. It was here that a bigger picture started to emerge. Climate resiliency requires durable material that can withstand nature's brutal impacts. The only tools in our toolkit, steel and cement, exacerbate the problem. 2 years down the line, here we are. At Recycle, we harness nature to grow durable material. We do this by growing a new class of cement from plant enzymes, mimicking shell formation, which bind aggregate into concrete. Nature's evolved to produce durable material without harming its surrounding environment. We expedite this process to cure at room temperature in a matter of hours, resulting in a concrete comparable to the incumbent that stores carbon rather than emits it. By mimicking nature, we're producing cement that repurposes metal ions like the oyster while capturing atmospheric carbon to build minerals. No fossil fuels, no mining. This unlocks a scalable, circular, and local supply chain to meet demand for climate-resilient materials. We're building a powerhouse team spanning commercialization, science, and design. With our core team, advisors, and growing talent, we're turning vision into impact with over a century of combined experience. We're doing this through piloting out of our lab, initially targeting our beachhead focus of coastal and reef restoration. Through piloting, we're co-designing with end users to unlock new bio-inspired possibilities, a faster cure time than industrial cement, 1 day compared to 27, point of use production, and reduced cracking. This is a tool for citizens that can be unlocked at low capex, empowering frontline communities to shape climate-resilient infrastructure. And by mimicking the structure and chemical composition of reef material, our material isn't just surviving in the harsh marine environment, it's thriving. In New York Harbor, it's attracted rare wild oysters to grow on its surface. This is material with the power to heal nature. We're testing Reef Cycle's durability and ecological impact to prove its value for people, profit, and the planet through global collaborations with the restoration community. And this is just the start. Our material is designed to evolve into seawalls, marine infrastructure, and eventually the built environment. With mix and pour capabilities, we're positioned for decentralized manufacturing, drop-in licensing, and strategic partnerships, unlocking a $596 billion market, delivering cost-competitive, high-performance alternatives to industrial cement. We've proven that climate-positive materials aren't just possible, they're here. With pilot deployments, projected carbon-negative production, and real market traction, we've done this without taking on dilutive capital. Now we're scaling a future where infrastructure actively regenerates nature, conserves resources, and serves as the bedrock for economic development. Over the next 3 months, we're opening our angel round, which will be a critical step in turning our technical vision
30 seconds.
Thank you. Scaling up our piloting capabilities and revenue generation, and growing our patent portfolio, positioning ourselves to enter the market with strong partners. And we're asking us to join us in changing the tide and scaling climate-resilient materials. Thank you.
Perfect timing. Thank you, Mary.
Thank you so much. And next up is Romain, all the way from Canada. And I'm going to regain control of sounds good. Romain, you're up next.
Okay, should be good. Hi, everybody. It's a real honor to be here, and thank you very much for the Biomimicry Institute for putting this up. So I'm delighted to introduce you to my company, Cellulotech, and our technology. First, let's start quick an overview of the issue. When you talk about the material transition, we have to consider how much material we consume every year. And the amount of unrenewable material we consume is around 80 billion tons every year. That's a massive scale. And if you want to build a new era of abundant and affordable materials, we have to work with what we have in the biosphere. And the most abundant organic compound on Earth is cellulose. Hence, we are trying to build a cellulosine by unlocking its potential and its properties. We start with the packaging sector, which is, of course, massive. And we've all seen this tendency to work towards paperization, which is replacing plastics and other material with paper. But one issue remains how we protect these papers and their content from the various elements such as water, grease, oxygen, and so on, to preserve and offer similar to better performance to what has been used in the past. So we need something that is competitive in the sense that it should be at most the same price as what it is today. Otherwise, adoption will be limited. We need to offer performance that are at least as good as the one that used to be used before. An example of the paper straw, which are an example that has kind of backlashed a little bit. Sustainability, we want to focus on things that are recyclable curbside rather than compostability because, of course, there's not enough facilities yet around the world. And scalability. This is massive. If we talk about paper and you were to put all the paper produce in the world every year on a roll, we would be able to go to the sun and back 17 times. So we need something that can scale material-wise there. And we propose our new breakthrough green chemistry. As you all know, if you put water in oil, it separates. You have this repellency, and that's what happens on a lotus leaf. And we're able to get this type of phenomenon and water repellency on cellulose-based material like paper by basically attaching 1 nanometer long molecules around the fibers. This is not a coating where you add a layer of material, so it's a much less material intensive approach, which allows us to mimic plastics, waxes, silicone, PFAS, and so more, and with a bio-based and recyclable material like standard paper. We use, on average, 100 times less material per square meter compared to coatings. We can be 50 times cheaper, as $1 of reagent can treat the equivalent surface of 1 football field. The result, of course, is 70 times less CO2 compared to traditional coatings. And our reaction time is 0.1 second. So when we talk about scalability, that's not much of an issue for us. There are plenty of market opportunities, of course, cardboard, even banknotes, membrane inside water, construction, food packaging, face masks, you name it. We've all validated those. However, we focus now on 3 main: cardboard corrugated to reduce resource consumption and replace coatings, waxes; paper hygiene to replace plastic liners; and release paper, which are basically the support of labels to replace silicone. These 3 markets alone cover more than 300 billion market, for which our technology is cheaper and offers similar to better performances. Our technology in the end allows to replace unsustainable and harmful materials with cheaper bio-based alternatives. We increase recyclability because many products that were not recyclable are now recyclable curbside like standard paper. We can reduce pulp consumption by 10-25% for cardboard corrugated, getting rid of this water issue. We can give more value to recycled paper and, of course, reduce especially CO2 depending on what we replace. So far, our samples have been validated. We have better energy projects. We have been approved for food contact. And most of all, we have granted patents and created freedom to operate analysis to go basically and license this process worldwide to all sorts of manufacturers. The team is centered around my co-founder, Danielle, a brilliant scientist, and myself, younger and more business oriented, as a famous TV show duo. And we are advised by heavy trans industry, namely presidents of former leader of paper packing OEM, as well as WestRock, the largest paper company in the world. Right now, we're fundraising $2.3 million and establishing partnerships to extend the range of applications and materials we work with. And I hope we can work together. Thank you very much.
Thank you, Roman. Okay, I think we are heading on over to Azul Energy.
I'm going to regain control of the screen. Yep. Awesome.
Oh, there we go. Awesome. Yeah, and we'll head on over to Masa, VP and CEO of Azul Energy.
Okay.
Oh, shoot. Sorry. My bad. We're back. Give me a moment.
I have too many screens open.
It's actually awesome because I can finally see everyone in the room.
Exactly.
And that gives me a lot of happiness. Here we go. Masa, you have control of the screen.
Yeah. Okay. Oops. Okay, so hello everyone. So my name is Masayuki from Azure Energy. So we are based in Tokyo, Japan, and spun from the Tohoku University in 2019. We invented high-performance precious metal-free catalyst for achieving net zero, inspired by hemoglobin. To achieve a truly sustainable society, we must significantly increase the adoption of renewable energy. However, expanding renewable energy requires large-scale energy storage solutions. One of the biggest challenges in this field is that current energy storage systems rely heavily on the precious metals, such as platinum, iridium, and ruthenium, as catalysts in their electrodes. These metals are not only the costly, but also face supply constraints and geopolitical risks, which could hinder the widespread adoption of renewable energy. At Azure Energy, we looked to nature for inspiration. In the biological systems, proteins like hemoglobin efficiently regulate oxygen reduction and oxidation without using any precious metals. So it's almost like energy charging and discharging. So drawing from this principle, we successfully mimicked the molecular design of the hemo group. This led to the invention of our Azure Energy, Azure Catalyst. So finally, we developed precious metal-free catalyst with exceptional catalytic performance. We've already filed 14 patent applications, of which 3 have been granted. Typically, there is a trade-off between the performance and sustainability in the catalyst technology. However, our Azure Catalyst breaks this trade-off, achieving both high performance and sustainability, making it the next generation solution. We offer our catalyst in various forms, powder, ink, and electrode sheets, making it adaptable for a range of energy storage applications. In the supply chain of the energy storage, so we provide catalyst or electrode sheets for the battery or system manufacturer. We power the future of renewable energy by delivering the key battery components. For the market entry strategy, so our initial focus is the battery storage market, a key segment in the renewable energy sector. Following this, we will expand into the hydrogen production and fuel cell markets, unlocking further potential for the clean energy solutions. We already have one strong partnership with a Japanese battery manufacturer. They have developed products using our catalyst and now are in the final qualification stage. Additionally, so we have 4 co-development partners, including energy storage customers, and 17 customers currently purchasing our catalyst for further testing, in addition to the 13 customers who are testing our catalyst at the feasibility lab scale. We are still a team of 14, but each member brings deep expertise in R&D or business development, making us a small but highly capable team. We already raised a total of $4.5 million for so far, and we are now planning our next funding round at the end of this year to raise $8 million. Join us in powering a sustainable energy future. Thank you.
Thank you so much, Mesa. And up next is Fiberly. So I'm going to regain control of the screen. That's such a great tool. We love it. Benedict, you're up next with Fiberly.
Yes, hi. Do I have control of the...
You can now, yes.
Okay, cool. Hi, everyone. How do I move the...
Are you all good? Yep.
Okay, yeah. Okay, here we go. Hi, everyone. I'm Benedict. I'm the founder and CEO of Fiberly. We are a French startup. We have labs in Buenos Aires, Argentina, and we are reinventing cotton. Very quickly, if you are wearing cotton today, you can react using the heart button at the bottom. Yeah, so cotton is with us, is everywhere. It's your favorite t-shirt, it's your favorite pair of jeans. It's from the military to the runaways, canvas bags, sneakers, etc. How big is this industry? Quite big. You have to think of the fashion industry as a whole as big as the economy of France. There's 100 billion garments that are made every year. And also in terms of production, there's almost as much virgin fibers produced as textile waste that is generated. And if we are talking just cotton, if you put cotton bales next to each other, you can go around Earth at the equator 1.5 times. Is there a problem with this? Well, cotton today uses huge amounts of water. There's forced labor concerns, heavy reliance on agrochemicals. That's for today. And for tomorrow, it looks complicated as well, as we depend on mainly 5 countries for 85% of the production. And all of those regions are in places that are very exposed to extreme climate events. And in terms of alternatives, we are limited to either fibers derived from oil or poor quality mechanically recycled fibers. But what is it about cotton that we like so much, in case you're wondering? Cotton comes from the cotton plant and has very specific structure. So a cotton fiber is a flat, twisted ribbon with a very specific architecture inside, which is concentric layers of cellulose polymers that are arranged at different angles. And that's very different from what synthetic fibers look like inside out. And that gives us the comfort we like, the breathability, the versatility, absorbency, durability, etc. Knowing all of this, what is it we are doing and what is our innovation at Fiberly? At Fiberly, what we do is that we take cellulose from discarded textiles and we repurpose that into brand new fibers that mimic the complex molecular architecture of natural cotton. And so the way we do this is you have to think of a process in two parts. This first green scalable chemistry. And then our innovation is focused on the second part, which is a physical regeneration process, where we use mainly electric fields to orient cellulose polymers and recreate that complex architecture. Here you can see on the screen, you have an experiment we ran where you see crystals aligning, and then you have the black and white picture is the vertical fiber is one of ours, it's a Fiberly fiber, and horizontal is a cotton fiber for you to compare. And that is the, and then the yellow picture is also a bunch of fibers of ours. And this is us, this is the team. My background is in the fashion industry as an executive in sustainability. Then we have Nico, who is our prototyping nanotechnology engineer, and also Juan, our specialist in polymers.
30 seconds.
We are raising a 2 million round now to keep building this, and we really hope you'd like to join us. And I'm very happy to connect. Here's my email and also my LinkedIn. Thank you so much, and looking forward to answering your questions and having a chat. And if in case you need shopping advice, I can also help. Thank you.
Awesome.
There we go. And then
Yes, over to you, Derek. Do you have control?
I'm going to request it. Let's see.
I'm
Awesome.
waiting for the access. Yep.
There we go. Well, over to you, Derek, from Source.
All right, cool. Let me see. Do I have control? Okay,
You
yep.
do.
Cool. All right. Well, hi guys. My name is Derek Saltzman. I'm one of the co-founders and CEO of a company called Source, and we turn waste biomass into non-toxic nanomaterials that elevate the performance of manufactured products. So today we're in a, well, if the screen switches. There we go. Little delay. So today we're in a world where manufacturing is nearing a breaking point with a lot of the current materials that we use. So in the past couple of years, you have over $2 billion invested in aerospace for fuel efficiency, over $20 billion in repair costs for construction. And even in the next 5 years, you have automakers that need to reduce their vehicle weight by over 15%. So they're looking to turn to affordable, advanced materials that can make their products stronger, lighter, and more environmentally friendly. Well, one of the big areas that everyone turns to is the world of nanomaterials. You've probably heard of this, from graphene to carbon nanotubes, kind of the big ones in the world that everyone's talked about. But there's a big issue with those materials. And one, they're really costly to make, so they're very expensive to produce. And two, a lot of the times their chemical compatibility of mixing into traditional manufacturing settings is just quite poor. And that's why at Source, we set out to solve that problem, where we empower manufacturers with advanced, low-cost nanomaterials from nature. We produce a functionalized nanocellulosic material that is 8 times stronger than steel and 10,000 times smaller than a human hair. You can actually see a photo of it on the right there. And what's unique about us? Well, we're 5 times cheaper than the incumbent nanomaterials on the market. We have a proprietary functionalization process that allows us to tune the chemical compatibility of that nanocellulose material. And the best part, we don't use any off-the-shelf hazardous chemistries. We built all the chemistry in-house. So it saves us on our manufacturing costs as well. Now, this is all based on our patented Rococell process, where we start off where we convert biomass, such as seaweed or hemp. We bring that into our facility and run it through our Rococell process, which is the novel functionalization process, where we use a variety of green chemistries. And one of the big competitive advantages there is that since we use these green chemistries, We don't produce any hazardous waste, so it saves on our CapEx, or I should say on our operating expenditures, because you usually have to pay about $3,000 per ton to dispose of that. And then finally, that leaves you with a final product called nanocellulose. To date, we have 2 patents filed with 3 more on the way. And we're tackling the $213 billion additives market, specifically focusing fiber reinforced composites. So that's the carbon fibers and the fiberglass fabrics that we utilize quite ubiquitously today, specifically focusing in sports and leisure products, aerospace, automotive, and a variety of energy sectors. So today, our sales pipeline, we've had over 30 commercial clients that are utilizing our material today. We've had over 25 purchases with 9 signed contracts, all the way around from consumer textile goods, all the way to aerospace companies. And even one of the companies here today is Zool Energy, who we're working with at providing some of our nanocellulose for their feedstocks. Now, this is just taking where we started out. So our first year, when we raised our first pre-seed round, was focused on a variety of applications. One was building out an amazing technical team to commercialize the company, was filing the patents and getting the R&D developed, and then receiving our first DoD or NSF-based grant. Moving into the next year, we're looking to build into our pilot facility, where the main goal is to transition the clients that we currently have from trial runs to fully paid pilots, with the desire of getting commercial offtake agreements to build into our commercial facility in 2027. Now, we built an amazing team. Mason and I have background in material science and
30
engineering,
seconds.
with working over about 4.5 years in the advanced material space with nanomaterial processing. And we put together a stacked team of advanced material researchers and business executives that have scaled and sold chemical companies in the past. Now, we have built the technology to enable this material transition. Now it's time to scale it. In the photo here, you see Mason and I about 5.5 years ago in our garage, to today where we have our first laboratory and commercial partners. We're backed by around a variety of investors such as Plug and Pay, Boost VC, and Founders Factory, and we're raising a $4 million round with 250 already committed, and we'd love to chat after. Thank you.
Amazing, Derek. Thank you so much. Round of applause for these first pitches. And we're going to directly dive in. I'm going to regain control of the screen whenever. Thank you, Derek. And we'll dive into the breakout room session. So it's going to start very soon. We're going to go for 5 minutes in those 5 different rooms. I encourage you to pick one of these startups to dive into one of these rooms. And yeah, feel free to ask any questions. You have 5 minutes. And Sarah, whenever you're ready, we can launch them. All right, welcome back here. We have another 10 seconds, so feel free to have a sip of water. Hey, welcome back. I know it was probably short, a short session here to answer a couple of questions, but we're on crunch time here and we have 5 more pitches to go. So before we dive in, a big thank you to our funders and corporate supports. We collaborate with thought leaders to support the work that we do, to support these amazing founders year-round. So round of applause for our supporters and funders, Bentley Foundation, the Ray C. Anderson Foundation, and L'Oreal. So thank you so much for supporting our work. And we'll dive into our second round of pitches. And I'll welcome to the stage Ilse at Gel Matter. Ilse, I'm going to give you control of your screen, and I invite you to unmute. Let me know when you're all set. Are we all good, Ilse?
Oh,
yep. Awesome. I
okay.
can see.
Yes. Good afternoon, everyone, or morning for those overseas. It's a pleasure to be here. My name is Ilse Nava. I'm the CEO of Gel Matter, and I'm happy to present the company and how we are making gels that are inspired by animal mucus. A little bit of background. Throughout my career, I always look at animals for inspiration in nature. So during my undergrad research and PhD dissertation, and during my postdoc, I had the chance to work with animal mucus, and it was fascinating to see how functional these materials are. From that work, I applied for a fellowship called the Activate, and with the support, I was able to transition from I was able to transition and launch my journey into entrepreneurship. You might hear the word mucus sounding like gross, but let me tell you that it has key functions in nature. It has lubrication, adhesion, protection, and many others. The chemicals industry are looking at taking these gels from the animals, but as you can imagine, this brings a lot of challenges and issues. It can damage the ecosystem, it can propagate viruses and parasites, and it's a material that is very expensive. So what we have been working on is a green chemistry and biomimicry combination to make materials, different molecules that emulate animal mucus. We can make the material as a powder and vegan version, and this brings different benefits, with lower cost being one of the key differentiators. Now I can take a moment for a poll, give me a thumbs up if you have not heard of people using snails in the cream in the face, for the face. Okay, so quite a divided room. So people are using, believe it or not, they're using the snails on the face because it has long-lasting hydration. And so our first market entry is to replace these materials with a vegan version. And so we can replace it for the snail skincare and up to any brands that create skincare products. We have also partnered with the Prime Coalition organization to assess how positively this impacts the skincare industry, as there is a lot of ecological damage. And our impact doesn't stop here, because our process can be tunable and we can have different formulations and different type of products to address needs across the industries. And so here I'm showing some examples, but our vision is to become a leader for biodegradable gels overall in the long term. So with this, I present you my team. We have expertise in chemistry and material science, plus a strong network of mentors and advisors. And we are currently entering a pre-seed round. So I invite you to scan our code, connect with us, love to chat. We're open to funding, investment, of course, and customer engagements and potential partnerships and collaborations. So thank you for your time.
Thank you so much, Ilse. Next up is Valerian Energy with Ahmet, who's going to share their own screen. So let's try that. All right. Amazing.
Hello, can you see my screen and hear my voice?
It's coming through. Yes, we can see and we can hear you. Awesome,
Okay.
Ahmet. Nice to see
Thank
you.
you so much. Likewise. Thanks, Miles. My name is Ahmet, and I'm the technical lead at Valerian Energy. Okay. And we are engineering bio-inspired nanomaterials for next generation batteries. As you know, increased carbon emission causes global warming, and batteries are at the center of decarbonization efforts through electrification. And traditional batteries face challenges such as low capacity, safety concerns, and supply chain issues related to raw materials like cobalt. So we need out-of-box approaches to enable next-generation battery technologies. Lithium sulfur is one of the most promising future battery chemistries. And however, this chemistry also faces challenges preventing its commercialization. Lithium dendrites are metallic growths on anode surface that can cause fires if not managed by the ion conductor in the middle. And it's a safety issue. Another problem is formation of polysulfide species on the cathode side. If these species move to the anode, they passivate the anode surface and kills the battery performance. So we need a new type of multifunctional material to address the safety and performance challenges. We need porous, thin, yet strong material. Combining these opposing properties in a single material is quite challenging, but such material exists in nature. Cartilage is a type of soft tissue that's found between two bones, allowing them to function properly. When we look closely, we see that the structure of cartilage is a 3D network of fibers. Inspired by the structure of cartilage, we engineered new type of synthetic nanofibers called aramid nanofibers. These are made from Kevlar, recycled Kevlar from used bulletproof vests. We provide a material that has high mechanical properties and high thermal stability along with chemical stability to enhance safety of the battery. And with the tunable pore size and reduced thickness of ion conductor, we can increase the battery capacity and enable fast charging. And these are all advantages for the battery performance. The battery market is growing and expected to reach about $400 billion per year by 2030. We have already patented our technology and now working on scaling it up in partnership with LG Energy Solution and other partners. We have combined our expertise in business and engineering to advance this technology to market. And we are looking for industry partners to scale up our technology and looking for investors for our upcoming investment round in the second quarter of this year. Thank you for joining us on our nature-inspired journey to engineer highways for lithium ions.
Yay, thank you so much, Ahmed. I'm inspired by this nature inspiration. I will allow Yunu, our next presenter, to share their screen. And whenever you're ready, you're next.
Hi, sorry, I have two screens and I lost my cursor. So yeah, let me start. Yeah. Hello, everyone. Thank you for joining. My name is Hyunwoo, founder and the CTO of Sienna Hill. And then let me start with our problem. You might already see and already notice what it is a hemorrhage and bleeding. It is a big problem in both clinical and economic sense. You may never know that it's actually over 1 million people dies globally per year by the bleeding. 90% of military combat casualties are from hemorrhage. 68% of surgeries have some type of major bleeding issues. And overall, it costs $14 billion and above become a burden in US alone every year. So it's a huge problem. So stopping bleeding is not very easy task. So we turn to our best teacher. Everybody here is nature. So in our cases, it was a barnacle whose glue mixed with adhesive polymer suspended in oil gives a superpower of sticking to wet and dirty surfaces. You can see it everywhere in seashore. Inspired by barnacle glue, we implemented into the biomaterial that can repel blood and form robust adhesive seal to actively bleeding tissue in less than 10 seconds. It was pretty exciting discovery in our field, and we published many papers when we are still working on the academic side of the game. And thanks to its unique biodhesive sealing capability of bleeding injuries, without relying on actual blood clot formation, it can stop bleeding in 10 seconds, regardless of the coagulation capabilities of patients during surgeries, as well as a trauma care in the field, which is almost more than 10 times faster than existing advanced solutions out there from big medical device companies, which is very exciting features. And beyond the bioadhesive paste in the first form that we developed, we built a diverse forms of adhesives in a strong platform for broad market opportunities in both medical devices as well as the consumer products. We have a very broad portfolio of projects already in our pipelines and with the partners, but it's keep growing with inbound interest and exploratory project with the potential partners. And we also care really a lot about the impact of our technology that we can make. We aim to offer a more affordable and accessible bioinspired solution for rapid, effective, and bleeding control that can save lives in both developed and developing countries. So like we have some specific goals, like we want to have a cost of goods 50% lower or less than existing biologic-based product, which is very, very expensive. And also we want to launch a product, this advanced products in the lower income countries as well, because we can make it cheaper than something out there already. And we also want to use more than 20% of the raw ingredient from plants or fungi driven. So it is having some environmental impact as well. With these exciting technologies and impact, we achieve a lot of attractions and achievements. We got nearly $5 million grant from NIH already, which I have a little nervous due to all those changes in the stuffs in the US, but it's a great kind of endorsement of our achievements. For temporary bleeding control in the field, we already formed a partnership with the military background team, tested in Ukraine last summer, which will have a 510(k) approval in coming quarters. And we did a great deal of a fundraising and a seed and Series A to support our programs toward the commercialization. And we also have a GI endoscopic applications. We formed a partnership with a very big medical device company whose 510(k) approval we expected to have a later half of next year. And for our PMA program, which is kind of one of our biggest program, is surgical bleeding control. We already finished the live animal demos with all of the major strategic companies in this space, which they're all interested. So it was all possible with our amazing team, with our advisors and also hospital collaborators, which is very nice to work with them from beginning to the current time. And for particularly, we're looking for interest in 3 areas for partnerships. We always look for partnership for new application through co-dev licensing or supply. We are also looking to expand the teams, especially in the quality engineering and business development. And although we raised money recently, but we always look out for engaging more with the investor for our future opportunities as we grow into the new applications. With that, I would like to thank you for your interest.
Amazing. Thank you, Yunwoo. I'll share my screen again. And that's the last screen share here. All right. Shen at Broker Mineral Resources Corporation, you're up next. And you have access to remote control. Let's make sure that you're unmuted.
I'm unmuted, but I don't think I can advance slides.
I think you can. You want to try again? You need to accept. All right. Here, there are many Shens here. I'm checking. Do you have access now?
I can't advance the slide, no.
Oh, good. I'll be here with you. I'll do it.
Thank you. Hi, everyone. I'm Sean Crow. I am the scientific co-founder and chief executive for Broker Mineral Resources Company. We're a Vancouver-based biotechnology company that is using biomimicry to build solutions for strategic metals supplies. I'm also a professor at the University of British Columbia here and have held the Canada Research Chair in geomicrobiology for the last decade. Next slide, please. So our inspiration for our technology comes from Earth's microbiome. Earth's microbiome is comprised of 10 to the 29 bacteria, which is an enormous number. And to give you some context, that's more than there are stars in the known universe. Our inspiration is thus abundant, and though it is unseen to the naked eye, it is everywhere that we look. Next slide, please. So these bacteria are critical for maintaining healthy ecosystems and regulating our climate, and they do so largely through their ability to process minerals. And they've evolved exquisite biochemistries to dissolve and precipitate minerals over their 3.8 billion year history on Earth. Next slide, please. And so Broker's mission is to leverage bacteria's ability to process minerals to improve the supply of critical minerals that are critical to global emissions reductions, and to bring down the nearly $1 trillion investment in mining and mineral processing that will be needed by 2040 to meet global emission reductions targets. Next slide, please. As an example that hits close to home, EV manufacturing is critical to all global emissions reductions, but this EV manufacturing itself is very metal intensive, and so it comes with its own environmental risks and contributions to emissions. Next slide, please. So a large part of the problem is a deficit in innovation that has plagued the mineral processing industry for decades. And this leads us to technologies that have enormous capital costs, are extremely energy intensive, and thus emit large amounts of greenhouse gases and toxic effluents. Next slide, please. So Broker has developed a nature-based solution that leverages soil bacteria in a bioleaching technology that allows us to convert wastes and stockpiled ores directly to high purity metal products that can be used, for example, in battery manufacturing or the construction of high purity alloys. Next slide, please. So our ability to take such a nature-based solution from the lab ultimately to a commercial implementation is really enabled by our diverse research and development team, which is comprised of a transdisciplinary collection of biologists, chemists, and metallurgical engineers. It's also supported by a creative business development team that has allowed us to develop business deployment models that we hope will enable our ability to interact with a notoriously recalcitrant mining industry. Next slide, please. So our biomimicry approach is proving a number of advantages. So number one, and our goal of going into this, is a greatly reduced carbon intensity relative to incumbent processing circuits. We produce no toxic waste. And interestingly,
30 seconds. Thanks.
We also have low capital intensity. So like you've heard from some of the other members of the cohort, bio-based solutions are not always expensive. Our solution also enables a streamlined supply chain and a number of value-added products that impart market resilience. Next slide, please. So Broker has an incredible opportunity to reduce emissions at a global scale, and we'd like to invite you to join us either as employees, advisors, investors, or more importantly, as broader champions of the biomimicry approach to innovation. Thanks.
Thank you. Thank you
Great.
so much.
And I think we are now heading over to New Zealand, over to Sentient Bio and Jonathan, our CEO, and our last pitch for today. So, Jonathan, do you have control? You ready to take it away?
We don't hear you yet.
Yep, sorry, just figuring out how to unmute myself. Hi,
Sounds good.
I'm Jonathan, CEO of Sentient Bio, and we're developing a new way to sense the world. What would life be like as an insect? Instead of sights and sounds, your primary experience of the world would be through smell and taste. That's how insects find food, find a mate, and communicate. And to do this, insects have evolved a smell superpower that gives them incredible abilities. For example, a bee can find a single flower over 2 kilometers away. This is in stark contrast to how we as humans approach chemical sensing today. The state of the art is a big, bulky mass spec machine like what you see here. These are expensive. Worse, they need to be in a lab with a highly skilled operator, and a single sample takes about 90 minutes. There must be a better way. We're mimicking nature to create an insect nose on a chip. This is one of our flow cells here in my hand. First, we use synthetic biology to produce the same receptors that insects use to smell so well. Second, we insert these into artificial membranes to mimic the cell environment. Each of these receptors then creates an ion current as it binds with different chemicals from a sample. We measure the current 4,000 times per second to see these individual gating events. This is the same information that's flowing to the projection neurons in an insect's brain. And then we mimic the insect's neuronal network by using artificial intelligence to interpret these signals and provide a quantitative measurement of the compounds in a sample. That gives us very distinctive advantages. First, we can provide unparalleled sensitivity. We've shown that our biosensors are highly sensitive and can record as low as parts per quadrillion. Second, it's really easy to use. It can be used anywhere by anyone. Simply add a sample and the software does the rest. And third, we stream the signal in real time, so we can quickly collect information to deliver insights in a matter of minutes. Our first focus is on the food industry. Food quality control is fundamentally about measuring what's in food and what's not, and customers and consumers want more and better information. The existing market is a fast-growing $7.9 billion unregulated market. Our ease of use and fast results can make a big difference to field testing, taints, and quality control. With our solution, you simply take a sample where you want, add it to a flow cell, and set your thresholds, and get a pass-fail result to take action. We have great early traction. In 2024, we won the startup competition at IFT First, the world's largest food science and innovation show. We now have pilots underway with 4 global food companies and a great pipeline of interest. Our solution can also have a huge impact on food waste and climate. The lack of quality information directly drives food waste, and incredibly, a third of all the food that we produce on Earth is wasted. Eliminating food waste in the parts of the supply chain that we're focused on could reduce global emissions by 7%. Beyond food, this is a platform technology. The biggest opportunity is to transform how we track and monitor our health. Our bodies are producing a stream of real-time chemical signals through metabolism that could provide early detection of most diseases. We've received a grant from the Bill and Melinda Gates Foundation to develop a prototype diagnostic for TB and malaria. We have an awesome team of 11 based here in New Zealand, bringing together expertise in biochemistry, structural biology, and neuromorphic engineering. Our seed round was led by Toyota Ventures and DYDX, and we have a great set of global partners. But we're looking for more to join our hive. Investors, we're looking to raise in the next 6 months, and we'd love to hear from you. Researchers, come and explore the power of our platform. And for the wider community, we'd love you to follow our progress and share your ideas. We're Sentium Bio. We're digitizing smell and taste to create a new way to sense the world. Thank you.
Thank you. Sensing the world through insects. I love it. Thank you so much, Jonathan. Thanks to all the speakers for this second group of startups, and we'll be joining our breakout room sessions again. So I encourage everyone here to stick around, join these rooms and chat directly with the founders. You have about 5 minutes. Gently welcoming everyone back in the main room. Thank you so much. I hope you had a great chat. And everything will be closed in 7 seconds. Hello, welcome back in the main room. Nice to see everyone. Thank you so much for sticking around, for engaging with these founders. We're about to close this first ever demo day of the Ray of Hope Accelerator, an initiative of the Biomimicry Institute. Thank you so much all for being here. And remember what we mentioned earlier today. Please give first. These founders can and will need support to grow and scale and have the impact in the world that they want to have. And yeah, we're really excited to be supporting them, and we hope that you'll find your own way to support them as well. A couple more words here. We would love for you to partner with us, so feel free to ping us, reach out to us. We're sharing some links in the chat with all kinds of email addresses to reach out to myself and to Sarah, as well as the founders themselves. And we would love for you to spread the word. So if you enjoyed these pitches, the work that we do. We would love for you to follow our newsletter, follow us on LinkedIn, and spread the seeds that we're planting here to have and build a nature-inspired world. Thank you so much for being here today. We have 2 minutes here to close out. So maybe, Sarah, if you want to have a last words.
No problem. I was frantically trying to add all of our last links and notes in the chat there. So we will be sure to share everything out and wrap up with the recording of this too. But again, I just want to thank everybody for being here. I know everybody's calling in from different time zones. I just saw that we've somebody calling in from India, so that is an insane time zone. So thank you for sticking with us and getting up and being here just to celebrate this incredible nature-inspired solutions that we have throughout the world that are really tackling the challenges that we have to realize a nature positive and resilient future. So thank you all for being here. But more importantly, thank you all to our founders. It's been an incredible 6-month journey with you all. We are so proud. Roman did just suggest that we can debrief around our next nature retreat together as a team. So fingers crossed we can get everybody together in the woods again someday soon. But thank you all for the work that you do. Continue to follow your passion for nature-inspired solutions, and know that myself, and the whole Biomimicry Institute team will be here to cheerlead and support you in every way that we can into the future. So thank you all again, and yeah, let's see what we can do for a nature positive future.
Amazing work. We'd love to hear from everyone here in the room. So please connect. Thank you so much.